All right, in this exercise, we are going to find a reflection in a hyperbola. The hyperbola is the function of y equals 1 over x minus 1. And also what we're going to do is we're going to sketch the reflection of that hyperbola, y equals negative function x. Now, what is function negative x? When there's a negative in front of function x, it's basically saying that y has become negative y. We've swapped y for negative y. And when we replace y for negative y, what that means is we're doing a reflection about the x-axis. So we're reflecting about the x-axis when we swap the y for negative y. So that's what we're going to do in a moment. But first, let's draw the original function. Now, the parent function to this hyperbola would simply be y equals 1 over x. But we've got our x minus 1. And if you remember from other videos, what we do when there's an x minus 1, that's a translation. That minus 1 actually means a shift to the right 1 unit. So that means we're going to take the parent function of y equals 1 over x and shift it 1 unit to the right, where the y-axis gets shifted to 1 right over here, and that becomes the new asymptote. So let's start to do this. So we know there's going to be an asymptote at x equals 1, and we know we're shifting 1 unit to the right, which is right there. So this y-axis goes here. So let me just sketch that in. Let me just put that in. Right there. Okay. That goes right through positive 1. So at 1, we have an asymptote. If I put 1 into this, 1 minus 1 is 0. 0 as a denominator is unacceptable. It's indeterminable, which means that's why we have discontinuation along here, which is where we put that asymptote. Okay, we've established the asymptote for 1 over x minus 1. As I said, we've shifted it 1 unit to the right. Now that we have that, what we want to do is give it a quick sketch. Now, in terms of sketching, if I do a rough sketch, y-axis, x-axis, a normal hyperbola of y equals 1 on x is just going to look like that. But what we've done, as I've said earlier, is we've shifted it 1 unit to the right, like that. So now we have an asymptote going through there, and now the curve's going to move to the right. So we're going to have the curve coming there and there. So let me just put in that curve right now. So usually with a hyperbola, I go across 1, up 1, like that. Then I go across 2, up a half. Then I go across a half, up 2, like that. And it kind of gives the right curve. So that's an approximate way of drawing it. But that's kind of what it looks like. So there's our function x right there, like that. So that's the top side. Let's do the bottom side over here. So what I like to do is go across 1, down 1, up 1, right there. Let's go across 2, down a half, down 2, in a half. So this is going to look something like this, our function. Like that, never touching the asymptote, getting closer and closer, but never touching. So we have a function x right there, which equals 1 over x minus 1. Get rid of that. It's positive 1 over x. All right. Function x equals 1 over x minus 1. There's our function right there. So we've got that. Now what we want to do is reflect it about the x-axis, as I said earlier, because we're looking for negative function x and we're replacing y for negative y. So let me go ahead and do that. So in order to do that, we got function, negative function x. So function x equals that. So negative function x equals, you just put a minus in front of that. Minus 1 all over x minus 1. So it's exactly the same, but we have a minus up there. So all the values change and flip about the x-axis. So this top part's going to flip down to the bottom, and the bottom part's going to flip and go up to the top. But before we do that, I want to see where it cuts the y-axis right over there. I want to find out where exactly it cuts there. So in order to find where it cuts the y-axis, the original function, that one there, we're going to substitute x equals 0. So let's go ahead and do that. So the original function function x is equal to 1 over x minus 1. 1 over x minus 1. Let's substitute x equals 0. So when x equals 0, that's the y-axis, this is going to equal 1 over 0 minus 1, which equals negative 1. So y equals negative 1. So when x equals 0, y equals negative 1, bang, right on the dot, it's actually going through there. That confirms it. That's pretty good, because now when we've reflected about the x-axis, and this goes up like that, we're going to know, just by looking at that, we're going to be hitting that 1 point right there. But we'll also confirm that later mathematically. So be on the lookout for that point. I'm going to put a mark there, because we're going to reflect it there. So let's continue back with this. Negative function x equals negative 1 on x. Let's do that now. Let's find out where it cuts the y-axis. Now it cuts the y-axis when x equals 0. So y equals, well, let's find out, that equals negative 1 all over 0 minus 1, which equals negative 1 on negative 1, positive 1. Right, so y equals positive 1. Let's have a look here. Y equals positive 1. There you go. Right there. That's exact mirror of that. So it's going to look like this. It's going to go there, there. I'm just estimating now. Just estimating. It goes like that. And then the mirror of that is that to that. And this mirror down here is going to look, let's see, that's one up there, one down there. And then we got that point there, and that point a half. I usually go one in, up one, up across, down a half, down two, up a half. So this is going to look something like that. Gets closer to the asymptote, never really touches. So now we got negative function x, and that equals negative 1 all over x minus 1. And you can see quite clearly the red has been reflected about the x-axis up like that, and there it is mirrored about the x-axis. So negative function x equals negative 1 on x minus 1. So we just put a box around that. That's our negative function x, and function x is equal to 1 over x minus 1.